This video in the SQL series is entitled Creating New Tables, and I'm Dr. Renaud at Shawnee State University. In this presentation, we will go over the SQL statements of create table, drop table, show tables, and describe. The discussion will include common MySQL data types used in creating tables, defining a simple primary key, defining a concatenated primary key, and adding a foreign key constraint to a table. The next two slides discuss the various data types available in the MySQL database. These same data types are available in most other databases also. The first is the Boolean data type, and the Boolean data type basically is a 1-bit data type that contains either a true or false value. It contains either a 1 or a 0. It's often used for yes, no, true, false, the value of checkboxes, that kind of thing. The second type of data, and a very common type, is the int or integer type. The int type stores a 32-bit value from, you can see 2 trillion negative to 2 trillion positive. So it stores a 32-bit integer value. There's also a type of data called the big int, and the big int stores a 64-bit integer value in the database, and you can see it goes from negative 2 to the 63rd power to positive 2 to the 63rd power minus 1. There's a float type and a double type, and the thing about the float and the double type is they store an approximation of a value, approximately 23 digits or approximately 53 digits of precision. But it's stored as a scientific number, as a mantissa, an exponent, and it's not an exact value, but it's a darn good value. So for a lot of scientific values, it works very well. The next type on this slide is the decimal type. And the decimal type, with float, double, and decimal, when you create them, when you define them, you define M, or you give two numeric values that go along with it to tell MySQL about the precision. The first value is the number of digits wide it should be, and the second digit is the number of those digits that are on the right side of the decimal point, or the fractional part of the decimal. So if you were creating a dollar and cent value, often 15,2 or 12,2 is used to make it a 12-digit number with two decimal points. Now, the decimal field type is different than the float and double in that it is an exact value. It stores a 65-digit exact number. So if you're dealing with money or inventory quantities or something where you don't want it rounded, where you don't want it estimated, where you want an exact value, the decimal field, but it takes a little bit more space. But most of the examples you'll see in our database creation and in this class, I use the decimal field for just about everything. Some more common data types include the varchar, which stands for a variable character, and when you're defining the variable character, you have to give it a length in characters that you want it to store. And what this stores is a UTF-8 string. You can use text, which automatically creates a 216 byte long or 216 character long varchar. It can be used. It's a real common way if you don't know how long a string is. That's usually a good value, just to use the text value. There's something called a blob, which stands for a binary large object, BLOB. And the binary large object is used to store images, sounds, or other binary data that you may want to store in your database. The date field is used to store a date. And whenever you're representing a date in MySQL and most other databases, it's advisable to represent the date in ISO format. ISO format is 4-digit year dash 2-digit month dash 2-digit day. As a computer person, you really should write your dates in ISO format all the time. It reduces confusion. It makes it so that international partners never have a problem understanding what a date is. The ISO date format is 4-digit year dash 2-digit month dash 2-digit day. Another data type in MySQL is the date-time data type. The date-time data type sounds just like what it would do. It stores a date and a time. And the date time should be represented when you're using it in your SQL statement. And when it's presented to you in a select statement, it will show as a 4-digit year dash 2-digit month dash 2-digit date, a space, 2-digit hour in 24-hour time, where PM is 12, 13, 14. Minutes is a 2-digit minutes colon, seconds is a 2-digit seconds. So you can see the format there, and that's how in your insert into statements, in your update statements, and other things, the date time needs to be represented. There are other data types within MySQL, but if you understand these and know how to use these in the context of this class, you'll be fine. And you can always look up the others and see how they're used in the online documentation that comes along with MySQL. So let's look at the first statement that I want to introduce, and that is the create table statement. So before we can add data to a table, it just makes sense we've got to create it. And when we're creating a table, we assign the table a table name, and then we have to define the column names and the types that go along with each column as we're creating our table. You can look at the tables to create table statement there in generic, where it says create table, table name, and then use open parentheses. And inside those open parentheses, you're going to list column name, the type of the column, the data type of the column, like we just discussed, any constraints that go with the column, and then at the end, we separate those column type constraint pairs sets with commas, and at the end we will add a comma and some additional constraints if necessary as we're creating our tables. Remember that each column must have a data type. Let's move on and actually look and see what a create table statement looks like in action. So here is an example of creating a table. This statement creates a table called item with 5 columns, and the item ID column happens to be the primary key. Let's look at the statement in detail and try to figure out exactly what it's doing. It says create table item, so that's creating the item table. The next thing says item ID int primary key. What that is telling MySQL is I want to create a column called item underscore ID. I want it to be of a type int. I could have said integer. And it also tells MySQL that this single attribute is the primary key. The next column is a description, name description, and is of a type text, so it'll store a 200 plus letter UTF-8 text string. The price is the next attribute, and it's a decimal 12-2, which means that it has 12 digits of precision, and it's 2 digits past the decimal point. Cost is also defined as a decimal 12-2, and quantity on hand is an integer. So this statement will create a new table called item. The next statement I want to introduce is a statement called show tables. It's a very simple statement. There aren't a whole lot of options to it. You just say show tables, and MySQL will show you all of the tables that exist in the database. Now, because we started with a fresh database for this demonstration, after creating the item database, you can see that we now have a table called item. Another simple statement that we often use as database people is the describe statement. And the describe statement takes one argument, a table name, and will show you the attributes and various definitions of a table. So by saying describe item, you can see the 5 columns, and you can see the data types, and you can also see whether it's a primary key and whether null values are allowed on the table structure. That's a nice way if you don't remember exactly what the table structure is, or if you don't have an ERD laying around, you can see what the tables look like. Another statement that you will need when you're dealing with and creating tables is the drop table statement. The drop table statement takes one argument, drop table, a table name, and it will delete the table definition, and delete all the data from the table. There is no undo when you drop a table. It won't ask you, are you sure you want to? It won't ask you anything. It will just do it. So be very careful with the drop table statement. So now that we know how to create a table with a simple key, we know how to see what the table structure is, we know how to list the tables that exist, and we know how to delete a table that we no longer want. Let us create a table with a concatenated key. When we're dealing with a concatenated key, instead of putting primary key beside the attribute or attributes, we have to put the primary key constraint at the end of the list of columns after we've defined the columns. And its format is primary key, open parenthesis, and a list of the columns that we're going to concatenate together to form the primary key, followed by a close parenthesis. Let's see that in action. So this statement creates a table called movies. Why do I want to concatenate the primary key for movies? Well, the reason is because there have been several movies made with the same name. It's just that they're on different years. The Blob was made several times in several different years. So the primary key of our movie table would be movie title concatenated with movie year. You can see that the title is a text, the year is an int, the director of the movie would be a text, the studio that produced the movie would be a text, the country where the movie was produced would be a text, and the primary key is the concatenation of title and year. The last thing I want to introduce in this video is adding a foreign key constraint. We understand that a foreign key is a primary key on one table that causes the link back to another table. And by defining the foreign key constraint, it will ensure that values in one table exist in the other table. We create a foreign key constraint by putting it at the end of the SQL statement, in the end of the create table statement, after we've defined all the columns, and the structure is foreign key, and then in parentheses you put this table's columns. The word references the other table's name, and then the other table's corresponding columns to this table's columns. You can see that we can put one or more columns in this and the other table's columns for concatenated keys. The columns may have a different name in one table versus another, but they must have the same data type, same data length, and same other attributes. So if it's a decimal, they have to be the same length. If it's a string or varchar, they have to be defined in the same length. So the foreign key constraint. In this example, I'm creating two tables. The first is the state table, which has a primary key of a state ID. Create table state ID varchar with a primary key, and then a name. So it would like have OH, Ohio, KY, Kentucky, TX, Texas. You can see the states. Then below, we create a table called customer. The customer ID is the primary key and is an integer. And if you look, we define the state ID right there, state ID varchar 2. The same as the state ID varchar 2 in the statement above. And then at the end, we say foreign key state ID references state ID. So that tells MySQL that there's a connection between the two tables, and it's the state ID on both tables that connects the two tables and connects the customer table to the state table. So on your entity relationship diagram, that would be a one-to-many relationship between customer and state. A customer has one state, a state has many customers. You can see on the described customer, after the customer table was created, that in fact it's showing up as a multiple key down in the key column, showing you that it is in fact a foreign key. I would like to thank you for watching this presentation. It was copyright 2019 by James M. Renault, PhD. You can contact me at jrenault@shawnee.edu if you have any questions. And this work is licensed under a Creative Commons non-attribution or Creative Commons attribution, non-commercial share alike 4.0 international license. And again, thank you.